Welcome to the Law of Conservation of Energy. In the last lecture, you learned about the types of energy. You learned about electrical energy, chemical energy, sound energy, light energy. There's all sorts of different kinds of energy. So what we want you to do today is list as many examples as you can think of where one type of energy is converted to another type of energy. So for example, here we've got light energy is projected onto a solar cell, which is converted to electrical energy, and that electricity is then used to turn a fan, which is a form of kinetic or mechanical energy. So see if you can jot down a few more examples of types of energy that are converted to another type of energy. Now, the law of conservation of energy states that energy is not created or destroyed. And also, energy can be transferred from one form to another. So this should not be new to you guys. We learned about this with the types of reactions. Our reactants always have to equal our products. Energy is just changed from one to another. So in this chart that you guys have in your notebook, here's a couple examples of how energy is converted from one form to the next. What I would like you to do is to go through each one and write down the type of energy. So for example, this first one right here, what type of energy would that be? It would be light energy. Light energy then can be converted into what type of energy to grow this carrot? Well, that carrot is chemical energy. So the light from the sun is converted to chemical energy, which we then eat as a human population. The next type of energy that you see up here is electrical energy. We can use electricity then to boil this water on the stove, and so we would list that as thermal energy. So electrical energy is converted to thermal energy. Down in the left-hand corner, this type of energy again is another food source. So just like our carrot, it would be chemical energy. We eat food, which allows us to move our body or have mechanical energy. And then the last one on here, this would be a gas pump, and that gas is a form of a chemical. So chemical energy can be converted and pumped into this car. This car will then move, and so we would call this car mechanical energy. So we can call this energy conversion as changing one type of energy to another type of energy using some type of converter device. So our chemical energy in our car is converted to mechanical energy because within our car there's some type of converter device. With that energy conversion, though, some of that energy is always lost. Even with us as humans, we lose a lot of our chemical energy when we convert it to mechanical energy. So for that car example, if it took 100 gallons of gas to move your car, that car is only 25% efficient, meaning only 25 gallons of that 100 actually moves your car. The remainder of the 75 gallons are going to be used for all sorts of other things, such as converted to heat. You feel the heat that you turn on in your car. You feel that the engine is warm. 29 gallons of it is used to cool the engine. 6 gallons is used to pump air through the engine, and the last 7 gallons is lost due to friction within the engine. So a lot of times we talk about how efficient vehicles are or how efficient our appliances are. Well, you can see a lot of our energy is lost due to waste. For us as humans, a lot of our energy is lost due to heat as we move our bodies around. So that concludes our lesson. At the bottom of your notes, though, here is a chart. So here's your opportunity to practice. What type of energy do I have to put in to a light bulb, which is my energy conversion device, and what type of energy do I get out? So go back and take a look at your types of energy notes and fill in the 6 spots on this chart to complete and fulfill the energy requirements.